Always remember, derivative of x can be directly written as 1 because it is 1 into x to the power 1 minus 1, which is x to the power 0, and hence we should take the value as 1. So from the trigonometric identity, the term cos square x minus sin square x is equal to cos 2x. So instead of this, we can write it as cos 2x. So we have applied the rule. Now find the derivative. X power 4 into, keep phi as it is, derivative of sin is cos x. Hello everyone, a warm welcome to one and all. This is Shruti ma'am, Department of Mathematics. So in this session, we are going to take up the derivative of functions. So last session, we have learned some of the standard derivatives and the rules to follow when you are deriving certain functions. So let us take the problems and derive the functions. Differentiate the following. So the process of finding the derivative is nothing but differentiation. Hence, we are supposed to find the derivative of the following function. So first question is, y is equal to x cube plus 4x square plus 7x plus 2 is equal to 0. So derivative of any constant function is 0 and derivative of x power n can be written in the form of n into x to the power n minus 1. And if you have a constant along with the function, we need to keep constant separately and derive only the function. So since they have given y here, I'll write dy by dx. So x cube can be written as 3 into x to the power 3 minus 1 plus 4 is a constant. X square can be written as 2 into x to the power 2 minus 1 plus 7 is a constant and derivative of x is 1 and derivative of constant is 0. Always remember, derivative of x can be directly written as 1 because it is 1 into x to the power 1 minus 1, which is x to the power 0, and hence we should take the value as 1. So if you have only constant, then its derivative is 0. But when you have a constant along with the function, you should keep constant separately and derive only the function. So now here, this is 3x square plus 4 2s are 8, x to the power 1, x plus 7. So this is the derivative. Next one, 5 secant x plus 4 cos x. So dy by dx is equal to 5. Derivative of secant function is secant x tan x. Next we have plus 4. Let's keep 4 constant as it is. Cos x is minus sin x. That's all. Next one. For the function f of x is equal to x to the power 100 by 100, x to the power 99 by 99 plus x square by 2 plus x plus 1, prove that f dash of 1 is equal to 100 into f dash of 0. First, let us find the derivative of this function. So f dash of x. So here 1 by 100 is a constant. So let's keep 1 by 100. And derivative of x per 100 is 100 into x to the power 100 minus 1. Because whatever may be the power of x, the derivative is always n into x to the power n minus 1. So looking at this, we can keep 1 by 99 as it is. X to the power 99 can be written as 99 x to the power 98 plus etc. And finally, we have 1 by 2 into 2x plus derivative of x is 1 plus derivative of 1 is 0. Now here, whatever you may get the value, it always cancels with the denominator given. So therefore, this will be equal to x power 99, x power 98 plus etc. plus x plus 1. So this is f dash of x. Now let's find out f dash of 1. So f dash of 1. So here x to the power 1. So from 1 plus etc. plus 1 plus 9. Until here, it is 99 times because here x we have x to the power 99. 1 to the power 99 means 1 itself. So we have 99 plus 1. This is equal to 100. Next, we will take f dash of 0. That means for the derivative found, we are finding the value at 1 and we are finding the value at 0. So this entire thing becomes 0 because it contains x. We are left with only 1. So now f dash of 1 is 100 times f dash of 0. Yes, it is. So f dash of 1 is equal to 100 into, what is f dash of 0? 1. So, f dash of 0 is 1. So, therefore, it is proved. Next one, y is equal to sin x into cos x. See here we have two functions which is in the form of a product rule. So, Leibniz rule says when you have two functions in the form of a product, then first function into derivative of second plus second function into derivative of first. This will be the derivative of the given function in the product form. So, therefore, by taking this as uv, then u dash and v dash depends on the function given. So, dy by dx can be written as first function into derivative of the second. What is derivative of second function? That is cos x plus second function into derivative of the first function, that is sin x. So, this is the product rule. So, keep first function as it is, derive. So, we will write d by dx of second function cos x plus cos x into d by dx of sin x. Now, here we have sin x. What is derivative of cos x? Minus sin x plus cos x into, what is derivative of sin x? Cos x. So, we have cos into cos, which becomes cos square x, sin into sin, sin square, but we have minus, so it is minus sin square x. So, from the trigonometric identity, the term cos square x minus sin square x is equal to cos 2x. So, instead of this, we can write it as cos 2x. So, therefore, the derivative of this function is cos 2x. Next one, x power 5 into 3 minus 6 x to the power minus 9. So, here we have a function dy by dx. So, here we have two functions, one is x power 5 and the other one is 3 minus 6x to the power minus 9. So, here we can also do this with the help of product rule, or we can multiply the term inside and derive them separately. So, this becomes 3 into x power 5, 3x to the power 5 minus 6 into x to the power 5 plus x to the power 5 into x to the power minus 9 becomes x to the power minus 4, because power can be added when you have the same base. So, 5 minus 9 is minus 4. Now, let us derive this. So, 3 into x power 5. So, 3 is with the function. So, keep 3 separately and derive this. So, what is x power n? N into x to the power n minus 1. So, 1 digit less in the power. So, x power 5 means 5 into x power 4 minus 6. Now, here we have a negative here. So, minus 4 x to the power minus 4 minus 1. When you have a negative power value just increases by 1. So, that is minus 5. So, the final answer is 3 5s are 15 x power 4 minus into minus becomes plus, 6 4s are 24 x to the power minus 5. This is the derivative. Next one, differentiate the following. So, we have x power 4, 5 sin x minus 3 cos x. So, this is already two functions. When you multiply also, you will get two functions. One is sin x, another one is x power 4. So, let us keep it as it is. So, let me consider this function as u and this function as v. So, let us apply dy by dx with product rule. First function into derivative of the second function, that is 5 sin x minus 3 cos x plus second function, this is 5 sin x minus 3 cos x, derivative of the first, that is x power 4. So, we have applied the rule, now find the derivative. X power 4 into, keep 5 as it is, derivative of sin is cos x. Next, keep minus 3 as it is, derivative of cos x is minus sin x, so it becomes plus sin x, plus 5 sin x minus 3 cos x into x power 4 becomes 4x cube. So, you can also multiply or you can keep it as it is. So, this is the required derivative. Next one, next question. Y is equal to x plus secant x into x minus tan x. So take this in the form of u, v and apply the product rule. So dy by dx is equal to first function into derivative of second function plus second function into derivative of the first function x plus secant x. So now we have applied the rule, find the derivative. So this is x plus secant x into derivative of x is 1, derivative of tan x is secant square x. Next we have x minus tan x, derivative of x is 1, derivative of secant x is secant x tan x. So now we have x plus secant x. So 1 minus secant square x is tan square x plus x minus tan x into 1 plus secant x tan x. So which is in the simplified form. Next one, y is equal to sin x plus cos x divided by sin x minus cos x. Now the function is in the quotient form. That's why we'll apply the quotient rule here. So what does quotient rule says? So when you have any function in the form of u by v, then the derivative of the given function is vu dash minus uv dash divided by v square. That means first function into, that means second function into derivative of first minus first function into derivative of the second divided by the second function square in the denominator. So therefore here when you apply dy by dx, sin x plus cos x is taken as u, sin x minus cos x is taken as v. So when I say vu dash, it is sin x minus cos x into derivative of sin x plus cos x. Next, minus u. So value of u is sin x plus cos x into derivative of, so v dash, that is derivative of sin x minus cos x whole divided by v square. So v square, v value is sin x minus cos x. So therefore it is sin x minus cos x whole square. Now we have applied the rule. Let us find the derivative. So therefore it is sin x minus cos x into, so derivative of sin x is cos x and derivative of cos x is minus sin x, minus sin x plus cos x. Here we have derivative of sin x is cos x and derivative of cos x is minus sin x, so which becomes plus sin x. So whole divided by sin x minus cos x whole square. So now let's multiply the terms here. We get sin x into cos x minus sin square x. So next we have minus cos square x. Next we have sin x cos x minus sin x into cos x minus sin square x minus cos square x minus sin x into cos x whole divided by sin x minus cos x whole square. Sin x cos x minus sin x cos x cancels. Sin x cos x minus sin x cos x cancels. Next we have minus as a common factor. Then we have sin square x plus cos square x whose value will be 1. Similarly, if you take minus as a common factor, it is again sin square x plus cos square x whose value is 1 divided by, So if you expand this, you will get this as sine square x minus plus cos square x minus 2 sin x cos x. So now again sine square x plus cos square x value will be equal to 1. Now the numerator is minus 1 plus 1 is 2 divided by denominator is 1 minus 2 sin x cos x is nothing but sin 2x. So therefore the derivative of this function is minus 2 divided by 1 minus sin 2x. Or if you want to change the sign, then denominator can be shifted to sin 2x minus 1 with positive answer. Next one, y is equal to 1 minus tan x divided by 1 plus tan x. So apply the quotient rule. Dy by dx is equal to, this is u, this is v. So v u dash 1 plus tan x into derivative of 1 minus tan x minus 1 minus tan x into derivative of 1 plus tan x whole divided by v square, which means 1 plus tan x whole square. So this is again 1 plus tan x into derivative of 1 is 0 minus tan is secant square x. Next we have 1 minus tan x. Again derivative of 1 is 0, tan is secant square x whole divided by 1 plus tan x whole square. Now secant square can be taken out, or we can take minus secant square x outside. So then we are left with 1 plus tan x plus 1 minus tan x whole divided by 1 plus tan x whole square. So now tan x minus tan x cancels, 1 plus 1 is 2. So therefore this can be written as minus 2 secant square x whole divided by 1 plus tan x whole square. So this is the given derivative. Next one, again the given function is in the quotient form. So dy by dx, we can directly apply the rule here instead of writing d by dx also. So if this is u, if this is v, let's write v u dash. So v is sin x, u dash means you should derive this. So when you derive this, x power 5 is 5x power 4, cos x is minus sin x, which becomes plus sin x. Next minus u v dash. So u is x power 5 minus cos x and v dash derivative of sin is cos x whole divided by v square. V square is sin square x. So we can also multiply this, which becomes 5x power 4 plus sin square x minus x power 5 cos x minus into minus plus cos square x whole divided by sin square x. Now sin square x plus cos square x value can be written as 1. So we have 5x power 4 minus x power 5 cos x plus 1 whole divided by sin square x. So this is our dy by dx. So in this session, we have found the derivatives of the functions which is in the product as well as the quotient form by applying the Leibniz rule. So this is the end of the chapter, limits and derivative. I'll meet you in the next session with the new concept. Until then, keep watching, keep learning and keep exploring. Thank you.